Okay, so in this video, we're going to discuss math operators. We'll go over some vocabulary and refresh ourselves on powers and logarithms. Um, so, just as a quick reminder, what is some math vocabulary that you need to know? Right? Here's a list of common words and which operator they're associated to. One thing to remember though is that less than gets a little funky because the than reverses the order of the two. So you're going to want to make sure that you memorize this table. All right, that's going to be super important. So that way you know how to translate the uh, statements. So let's take a look at some examples here. So first example says difference of 6 and 8. So difference says, let's see, difference is right here. It's under subtraction. So that's telling me I'm going to just subtract here. So difference of 6 and 8. 6 is what's going to come first because that came first in our statement. So 6 subtract 8. All right. Evaluate it. That's going to be negative 2. Next one, quotient of 28 and 4. So if you don't remember, right, we take a look at our list, see if we can find where quotient is. Quotient is to divide. So when I take a look at that one, so again, we read right to left, that's going to go first. So 28 divide 4. All right, so that first number is going to be what's on top, or is what the divisor is. So then 28 divided by 4 is 7. So that's going to be our answer here. Right. Next one, we have 12 more than the product of 3 and 4. So we got to be careful here. More than means to add. Product means to multiply. Here we're going to multiply 3 times 4, and then we're going to add 12. Right? You'll notice that here I did switch around the order, but remember for addition, order doesn't matter. So, 12 plus 3 is the same thing as 3 plus 12. So it doesn't matter here. So there's our final answer, or actually, there's our expression. If we evaluate it, we're going to end up with 24. Double a number and divided by 10. Doubling, remember, is a special case of multiplication. So a couple things to remember. When we see multiplication, double means to multiply by 2. Triple means to multiply by 3. Twice is also means to multiply by 2. So be mindful of that. And obviously this chart or this table is not every possible word, but it's a lot of common ones. So double a number. So this one's going to have a variable. A number, we'll just say it's x. Double means to multiply 2. And then divided, it's pretty self-explanatory there, by 10. So we're going to double a number and then divide by 10. All right? And so that's going to be our translation. Now, the next thing on this particular topic is going to be reminding ourselves on how to read powers and logarithms. So let's take a look at powers first. Remember that we have a power. A power is this whole statement. So this whole thing is what's referred to as a power. So that's a power. Okay. The larger number, as in like larger print, that's your base, right? The number that's in superscript, that's your exponent. And remember, powers mean repeated multiplication. All right? So when I take a look at an example here, right, 4 is my base, 3 is my exponent, the power is 4 to the third. So remember that this is going to be, so we should be thinking, right, how do I evaluate that? That's going to be 4 times 4 times 4. Okay, that's what we're thinking. And our final answer is going to be 64 then. All right. Logarithms, all right, look like this. You're always going to see the word log. Sometimes you might see something called natural log. Sometimes you'll see a natural log. That's an L and an N. That's if you see a log with no subscript number, that's common log. In this one, we still have a base. So this is a base. And this x here represents the power. Okay? So when you're thinking about a log, when you're reading a log, it's kind of like a power backwards, right? So because what's missing here is the exponent. So when you evaluate a log, what you're actually looking for is the exponent. So when you evaluate a log, right, that gets you the exponent. All right. So you need to be thinking, right, what when you see this whole statement, you need to think, right, what exponent of this base, or of this A, gets a power of x, right? So when I take a look at this first example, I need to figure out, hey, what exponent of 3 gets me a power of 81, right? And so if I need to evaluate that, something that you could be doing is you could be figuring out, well, 3 times 3, that's going to be 9. 3 times 3 times 3, that gets me 27. Right? 3 times 3 times 3 times 3, that gets me 81. So that means then, right, my exponent here is going to be 4. So the answer here is 4. Right? That's our answer. All right. Now, if you don't have these memorized, right, or what power should you have memorized, right? I've got a nifty table here, right, that you can read kind of like a multiplication table, but for power. So like 2, so I'm reading, here's 3 to the second power. That's going to get you 9. 3 to the third power gets you 27. 7 to the second power is 49, right? These are all common powers that you should be familiar with. All right?